All right, let's continue our series on differential equation. Now let's look at types of differential equation. Differential equation are of different types and forms, but let's generally classify differential equation into these two broad classes. We have the ordinary differential equation, which is ODE, and the partial differential equation, which is PDE. What is an ODE? What's an ordinary differential equation? This is a type of differential equation that involves one independent variable. It involves one independent variable of the given function. Okay, and it describes how a function is changing with another with respect to another variable. For example, if we have y is equals to f of x, so you just have this function having only one independent variable, which is x. So we can have function as the y, the x equal to sine x. This is an ordinary differential equation because we have only one independent variable, which is x. We also have another one as if we have x, the second derivative of y with respect to x plus sine x dy dx equal to cos x. This is still an ordinary differential equation because the independent variable is just x alone. All right, we have more examples of this. Then let's look at the second one, which is PDE, partial differential equation. Partial differential equation involves multiple independent variables. And this kind of differential equation is usually used to describe systems with more complex behaviors, seems like heat transfer, fluid mechanics, quantum mechanics, and so on and so forth. So if you have a function, say u is equal to f of x comma y, where x and y are the independent variable, u is a dependent variable. So this function depends on two variable. Okay, we can also have u equal to f of x comma y comma z. We have three independent variable here. So when we are differentiating this, we differentiate partially with respect to each of the variable. So this will lead us to examples like partial u. You can see that this is different from this. This is a total differential. This is partial differential. Okay, total is this, partial is this. So partial u with respect to x, partial x plus partial u partial y plus u equal to exponential x minus y. This is an example of a partial differential equation. It contains two independent variables, which is x and y. We can also have a second derivative of it, or we can have this uxx plus uyy equal to 0. This is still a partial differential equation, where u subscript x simplify partial u partial x. Uxx means the second derivative of u, the partial second derivative of u with respect to x, and uyy means second partial derivative of u with respect to y. So these are still examples of partial differential equations. So point to note, for an ODE, it contains one independent variable, while a PDE contains multiple independent variable where you need to find the partial derivative of the function with respect to each independent variable. Thank you so much for watching this video.